Hey, it's Jag. Welcome to Base Pre-Engineered Edition Episode 8. Projects on this channel often involve high voltages. Please do not attempt these projects unless you are experienced and understand the risks. Welcome back. Episode 7 completed the mechanical preparation of the base pre. We're ready now to move ahead to the final assembly stage. Today's goal is to complete the power section, have it completely wired up, and to test it. The power supply is the foundation for everything that follows after. So it's very important we get that right, get it fully tested, and make sure it's solid and stable. Between the last episode and now, I did a few things off camera. The first thing was I relocated one eyelet. This eyelet right here was just a little too close to the shell of the boost converter for me to be comfortable. So I drilled that out and installed a new eyelet just a few millimeters over, just to give me some breathing room, and I'm a lot more comfortable with this now. Inside the chassis itself, I've permanently mounted the tube sockets to the L bracket. I've installed the front and rear grounding lugs. I epoxied and soldered the boost converter to the power card. So that's epoxied on there, nice and solid. And I've wired the input and output for the boost converter to the eyelets it's going to go to. Also, since I had the boost converter taken apart, I've reapplied thermal grease behind the MOSFETs, and I also siliconed the diode back to this sidewall. I used the RTV silicone for this. So workshop tip, neutral cure RTV silicone is the best thing to use for electronics. Unlike the common silicones which contain acetic acid, they are acidic. The RTV silicone does not have any acid, and it's safe to use around electronic components, copper, solder joints, and component leads. So I use this Mono Silicone Max. It is a neutral cure silicone, and you can get it at any home store. I got this at Home Depot. I also installed the standoffs, and you can see I've also installed the preamp circuit card, the transformer, and the L bracket. All of those standoffs are secured with thread locker, where I don't expect that we will ever have to take them out. Medium thread locker, so we could take them out if we needed to. Any of these that may need to come out for some reason in the future are secured with a Kep's nut. Also, the preamp card and the transformer and the L bracket being installed here, I can still take them out if I need to. Hopefully I won't need to do that. Hopefully they can stay there now until this is complete. But I did not use any thread locker to secure those in place, and I wouldn't, because those are components that may need to come out for some reason down the road. So now I'm going to get on to soldering the power circuit card. I'm going to mount all the components that live on the card first before I install the card into the preamp chassis. I'll do that as a time lapse right now. You don't need to see a long session of boring soldering. Well, make no mistake, installing the circuit card into the chassis and then wiring to the switch, the fuse, and the DC input jack is definitely and by far the most frustrating part of this build. There probably won't be anything more frustrating than doing that. But that's the nature of the beast, and especially when you're building with solid core wire, which I am doing here in a sort of high watt style. You don't want to be moving those wires around more than you have to, because they will break literally after a few times being flexed. Everything went okay. I got it all done and in there. Before I put any of the components on, I did confirm their values, make sure they were the values they should be. Everything is bang on, so I know there's no problem with the components. One thing I didn't do was test this boost converter standalone before I put it in. This is a new boost converter. The one that I used in the prototype will be redeployed to the version of the preamp that I built for myself, but that's still in the prototype preamp. So even though I hadn't tested the boost converter, I thought, well, I've got it installed, I've got it all wired up. What could happen? I know what could happen. The worst thing that could happen is if I wired it wrong and blew something, and then I'd just have to undo all of this. Pretty sure there was nothing wired wrong. I'm going to check that before I fire it up. We're going to do that right now. So the only real thing would have been is if this new boost converter actually was defective right out of the box, and I doubt it is. So as I say, we're ready to fire it up. Not the preamp, but we will be firing up the power supply. My impulse as a tube amp builder is to plug everything into my dim bulb tester and run in a restricted mode right off the bat. And I was going to do that here, and then I started thinking, well, wait a minute. It's a switch mode power supply. It's a boost converter. The switch mode power supply is designed to work on any voltage from about 90 volts up to about 260 volts. And no matter how much voltage in that range you give to it, it will give out exactly the 12 volts you're expecting. Actually, I measured it was 12.2 volts. And so I don't know how much, I haven't checked in years how much my dim bulb tester brings the voltage down, but I was pretty sure we're still going to be in a pretty good range for running the switch mode power supply. And I did test it on there, and yes, in restriction mode with a 100-watt bulb in my dim bulb tester plugged in, I got exactly 12.2 volts DC on the output. When I switched it off restriction mode, it was still exactly 12.2 volts DC. That's the whole draw about a switch mode power supply and the boost converter, is they are very stable regardless of what's coming in, and that is going to make the preamp actually perform in a much more predictable way. If the power's browned out a little bit one day or a little too high one day, it's not going to affect the voltages in the preamp, so it's going to stay a lot more consistent. So that's just another little tech tip. I don't really think a dim bulb tester is useful when you're using a power supply like this. Before we plug this in and power it up, though, I want to double check that I've got continuity everywhere I should have, that everything is connected as it should be. I have gone through and visually verified that everything is soldered in the right places, but I don't know for sure. I haven't got a short underneath the board, or I haven't miswired something, or a wire broke or didn't get soldered and I didn't notice. So we're just going to go through, do a quick beep test on my multimeter. We're not checking component values or anything. We're just checking that we've got connections everywhere we need connections. And I will start with the grounding. So I've got my ground probe connected up here to the negative side of the heater power supply. The grounding path is common all the way through this whole thing, on the input side of the boost converter, the output side, to the twisted pair for the LED strip, and even to the output of the high voltage side of the boost converter. So this will just stay on there as my ground connection. So we're going to check grounds right now. So I should have, and of course I have not wired the heater supply to the tube sockets yet, nor have I wired in the LED strip. We are checking just the power supply, and we want to make sure that we are getting power where we need it, when we need it. So you can hear, or maybe you can't, we have continuity right there, we should. If I come back to the DC input and check its negative terminal, I have continuity there. I also can check to where the input, the negative input, connects on the power circuit card, and we've got continuity there. That's sending up to the heater supply. It's also sending through jumpers all the way through to my filtering capacitors on the input, to the negative input to the boost converter, and to the negative side of the LED strip. So we'll just check that whole thing. So again, here's where sort of the main connection is. We got continuity. I follow back to my first filter capacitor, got continuity. The second filter capacitor, and again, when I say filter capacitors, these aren't the DC filter capacitors. They're just filtering the incoming 12 volt DC, not the high voltage output, just to help discard some of the noise that could be on that line. Now the negative feeding the boost converter, continuity there, and the negative feeding to the terminal or to the LED strip. We have continuity there. If we also check up here, the ground for the terminal strip is seeing that continuity. And if we check the ground on the output side of the boost converter, oh, it's not turned on. I think it's not reading right now because the boost converter isn't powered. We'll see what happens. So anyway, that's the whole negative side of the circuitry. Now what we'll do is we'll check where all of our positive connections are going. The positive input on the DC input jack is right here, and it should be going to the fuse right here. We have continuity, and it is going through. It should pass through the fuse, and then it should go to our power switch. And that's working too. Now our actual power switch is set in the off mode, so I should not get anything on the other side of that switch going into the boost converter or to the heaters or LED strip. And I don't. We have no continuity there because it's turned off. Now, if you recall, I have this set so that in one position the switch will turn the preamp on, but not the edge lights, the LED strip. And in the other position, it will turn on both the preamp and the LED strip light. I'm going to test the no lights path first, and that's when I have the power switch down, the chassis upside down, so down is this way. So now, if I connect to the DC input to the switch, and then I check the hot for the heater supply, we do get continuity there. If I check it at the input to the boost converter, we've got continuity there, but I shouldn't get it on the power send to the LED strip. And I don't, not at the board and not where the LED strip will connect. So now if I switch the switch into lights and preamp position, now I should get continuity on the DC or on the positive side of the supply all the way through up to the boost converter. So we're connecting the main power input. I can check the heaters, and that's got continuity there. I can check the input to the boost converter. We've got continuity there. I can check on the card the send to the strips, the LED strip. I've got continuity there. And at the terminating end for the LED strip. So switching wise, power switch wise, everything is working. Of course, I won't get anything on the output side until we have power here, but I do want to check that my ground rail or my negative side has continuity all the way through to the ground or to the negative connection to the preamp card. So I'm not going to check every node. I'm going to check the first where the negative output from the boost converter comes onto the card, and just check where it should terminate all the way down the end of the string. And there's continuity there. I'm also going to check that my B+1 and B+2 are connecting and seeing what they should. So that's B+1, and that's working. And B+2 is right here. We'll check that. And we've got B+2 working. So doing the beep test, the continuity test all the way through, everything's looking okay. So now we're ready to Moment of truth. Fire it up, see what happens. Be ready to turn it off really fast if things seem to be going south. I'm going to set my meter to DC range. I'm going to run my negative probe all the way back up here. If I can leave it on this connection for all of the tests all the way through, I will. I may have to move that over to the negative output from the boost converter if I'm not getting anything there. So at the moment, we're ready to fire up. I haven't plugged it in yet, and I'm making sure the switch is in the off position. I'm going to plug in the DC brick and connect it to the DC input on the preamp. So I've got it plugged in. I should see DC at the input jack, and there we are. We're 12.27 volts DC. I should also see that going into the switch from the fuse. Yes, so our 12.27 volts DC is getting all the way to the switch. So the only thing left to do is turn it on. I'm going to start with it in the no lights position. You won't see lights today because I don't have the strip connected, but I'll start with it in the no lights position, and we'll check that we've got 12 volts at the end of the heater string, that we've got 12 volts going into the boost converter, and that we don't have 12 volts coming out the LED strip yet. And we won't test the B+1 and B+2 outputs either until we've tested the LED strip positive voltage as well. So first of all, we're going to fire up, one hand behind our back, and be ready to kill the power if anything seems to go south. Okay, blue light, nothing sizzling, no smoke. Everything seems okay. So let's just take a look and see what we've got. Up here at the heater supply, yeah, we've got 12.21 volts. On the input to the boost converter, 12.1 or 12.21. We should not see anything on the input to the LED strip, and we don't, and we shouldn't see it here either. And we don't. So everything coming in is looking good. So, and we still haven't smoked, nothing's burned up. I'm going to switch it into the lights and preamp mode, and we'll just recheck all of the input DC from the heaters to the boost converter to the LED strip. So up at the heater end, 12.21 volts. Over here on the input to the boost converter, 12.21 volts. On the input to the LED strip, 12.21 volts. And at the terminating end for this strip, 12.21 volts. It was not quite getting there because the wire was trying to walk away from me a bit. Now the big moment of truth. I'm going to move the meter over to this side. Hopefully you'll still be able to see it. And we're going to check B+1 is here and B+2 is here. We're also going to check whether we need to connect to that ground or not. And I will connect to the ground just to show you that the voltages don't change anyway. We do have a continuous ground all the way through. Here we are. We're at 0 volts right now. I connect here. And we've got 300 volts at B+1. Oddly enough, that's what I was shooting for. This is adjustable. I did kind of eyeball it. I eyeballed it right. We're at 300.3 volts at B+1. At B+2, I was hoping to get somewhere between 275 and 290 volts DC, hopefully a little higher, maybe 285. So let's see what we got there. 287. So everything's looking really great. We got 300 volts at B+1, which is what I want. It's what I've spec'd for this. And we've got about 287 volts for B+2, which is also within the spec I designed it for. Just to show you that that ground is continuous all the way through, I will connect my ground probe over to boost converter negative output. I keep calling it ground. I guess technically we should just be calling it the negative side because it isn't actually grounded to the chassis. So we've got that on there. And again, if I check B plus 1, getting 300.1 volts, and B plus 2, 287 volts. So it's doing what it should. So what about how I nailed that 300 volts? Is that just the way it's designed and the trim doesn't actually do anything? I might want to lower the output voltage or raise it. We probably should double check that that does what we want it to do. So what I'm going to do is I'm just going to test this by adjusting B plus 1. B plus 2 will follow. If I raise the voltage, B plus 2 will come up a bit or go down a bit or a lot, depending on how much I raise the overall boost converter output. As long as the B plus 1 is going up and down, I know that B plus 2 will go up and down. I don't really need to read that right now. That will be more for when we're fine-tuning the base pre. We've got 299.9, 300 volts. It does fluctuate a little bit. And I'm going to first turn this down and see if it starts going lower. And this, I forget how many turns this pod is, but it's a lot of turns. So it takes quite a bit of change to register a major difference on the meter. But I'm going to turn it counterclockwise, which I presume will lower my voltage. And it is. I'm not going to check how far we go, but now I've got my B plus 2 down to about 250, actually about 243 volts. I wouldn't actually run my B plus 2 that low. So that's a good low range for it anyway. It will change when there's a load on the outside, but it's good to, or on the end, but it's good to know this. So now let's crank it up. Now, I don't want to go too high. I'm using one of the filter caps in here is 500 volts, the other one's 450. So I don't really want to go to 450, at least not for too long. But that is way higher than I would run the preamp anyway. I'm going to check and see if I can get to about 350. That would be really the highest I would ever go. And there we are. Yeah, I'm already at 362. It's still registering that change. So I've got a good range of my voltages. I'm going to take this back to 300 just so it's there when we're ready to go. And as you adjust this, it's just like a bias control, really. You have to let it kind of settle, even though there's no tubes in here. As you turn this, once I stop turning, it still drops 2 or 3 volts. So as I get closer to the voltage I want, I just start kind of just nudging it, not so much turning it. And there we are. We're set at exactly 300 volts. I'm going to turn this off before I forget because I do have live wires here. That's okay to do when you're testing if you know what you're doing. And if you don't know what you're doing, you shouldn't be doing any of this. You can see that the voltage is draining because I have that bleeder cap, but we're still at over 100 volts here. I'm just going to use my little trick here to bleed it down quickly because I can't remember what I call that. Okay, we're down to 4 volts. It's still dropping a little bit. We'll just leave that on there while we're talking. I'm going to unplug the power cable that goes to the brick just so I can't accidentally plug myself back in. So that's really great. I'm really happy, really excited. What it says to me is we are truly ready to wire up the rest of the preamp. The whole power supply is stable, solid, works the way we want, and that's kind of the most important thing during building it. It's the most important thing until we want to see how this sounds. So we know we've got a solid power supply and it's working well. A big thing about this, even though I said this was a frustrating part, all of the planning ahead, all of the mechanical design and planning really helped make this go smooth. I didn't have any major troubles. I should say I did have to add another eyelet in on the board here. It just wouldn't take 5 leads, and I had 5 components that needed to go into one eyelet. So I installed an eyelet, and that allowed me to put a jumper to the eyelet, to the new eyelet, and move 2 of the wires over there, and then everything fit fine. That is not a problem. It's not something we missed. It is something that I kind of expected, and I could have put it in the original design. When I update my documentation for this, I will put that eyelet in there. So we've done all of our polarity checks. We've done all of our power checks or continuity. We don't have any solder bridges. We don't have any cold solder joints, anything not connected. We're good on that front. So the power supply is done. We're ready to go. We're ready to move on. What have we learned? The main thing we've learned is that good engineering removes future problems before they become problems. We've learned that the best first power-up is one that's not exciting, and this wasn't. It's exciting from the point of view that it works, but we didn't have any fireworks. And we're not trying to finish the project in a hurry. We're trying to finish it properly. So that brings us to the end of this video. Some of you who follow my channel closely have probably realized that it's been 3 weeks since the last video, the ASMR video. I'm not going to try and stick to my schedule of getting a video out every week. I find I end up rushing things a little too much, and I would rather make quality videos rather than rush things and get content out every week. So I'm going to switch to an every other week release schedule for my videos. So if you're following my projects, first of all, thank you. If you are used to me releasing things pretty much every week, I am switching that to every other week. The whole idea is my content will be served much better. So that's the end of this video. Like always, please like and subscribe. Thanks for watching. Check my band One Soul Thrust. The links are in the description below as always. We've got some news coming for One Soul Thrust sometime in the next couple of weeks as well. So keep an eye out for that. I'll announce it here. And until the next video, we'll see you. Future Jag here. It's about a week later. I was just finishing this video, getting ready to put it out. It's about a week later than I thought I was going to be releasing it. So it's been 4 weeks since the ASMR video, my last video. At the end of the video, I talked about some exciting news for One Soul Thrust, and I can announce it now. We've just released a new video for our song Yes, from Slaves to the Sky, Masters to the Mess. So that was just released a few days ago. I'll link it below. Thanks a lot.